Wake up. Let's see, I can turn off AutoCAD for this for now. Oh, there we go. Let's see, chapter 8.
Shouldn't you be able to just look up the C-channel moment of inertia in the back of the book in one of the appendixes? Is it there or no? Yeah.
Just steady. Get this captured, then we'll go from there. Thought I closed that. Keep asking all these questions. Wait a minute, that's what I said you should be doing, right?
Yeah, you told me to.
It's coming back to haunt me. No, not at all. Okay. In fact, you have to look some of that stuff up in the back of the book. That's why I wanted to do this problem. Because, like the C channel, that C channel, realize, has like a little radius right in there. It's kind of a complex shape. There's a little radius right there, and there's a radius there on both ends. There's not on the corner. That's usually pretty squared up. So, and it's on a taper, right?
Page 491. Appendix C, 92 on page C1.
Just happen to have that marked. How about? Oh, okay. I had the I-beam. It's a different problem. 490 what?
1.
Okay. There's your C channel. Now it says in the problem, the C channel is C 15 by 40. Okay, so you'd go to the back of the book there on page 491, and that's the second row down from the top, right? And it says the area. So if we called this, let's call this area 1, and of course area 3 would be the same, right? So they could both be A1s, or you could call it A1, A3, and this would be A2 right here. So it tells you that area 1 is equal to 11.8 square inches, right? Does make a difference. It also tells you that the D value, this distance from here to here, is 15 inches. Does that make a difference? Probably does, doesn't it? So you can find out what your Y bar is. Now, and that's the only two things we really need out of that problem for the XX. If we were doing the YY, we'd have to have a couple more dimensions there, wouldn't we? But note, there is no there is a moment of inertia, isn't there?
Second
Yeah.
column over.
348 is the X.
Yep. So the moment of inertia for the x-axis is 348
Y is 9.
square inches, right?
Four.
Yeah. I was writing it as I said it. Plus, remember, if I say right at the end of the sentence,
That's for the centroidal axis?
that's for the centroidal x-axis.
Just on that one C channel. Though.
That's just for that, each of those C channels.
Yeah.
That particular shape, that channel shape, okay? That's, and then it also gives the YY, and it gives some other things in there. Does it give the, it doesn't give the, it gives the radius of gyration, doesn't it? But it doesn't give the J, the polar moment of inertia.
No.
But we would have enough to go ahead and figure that, wouldn't we? I think we've got enough now. So that takes care of that one. Now what about the cover plate?
You don't want the Y.
No, we're just doing the X. Okay, we'd just be doing the X on these problems. If I try to get you to do the X and the Y, we'd never have enough time to get a test done. You struggled as it was to get the last one done, so concentrate. If you can do one, I'm pretty sure you could probably do the other. I'm guessing. Okay, so now the other channel then, if I can find my mouse again, there it is. Okay, the area of 2, and my writing is bad today. It says that cover plate is 21 by 7, so the 27 by 1, so that area is going to be 27 square inches, isn't it? The D on that one, and I'm not too wild about that, but that D on that one is actually 1 inch, isn't it? That's the total height, if you will. What's the moment of inertia of that one?
How do you know it's 9? 27.
Do what?
Is the height of the plate.
It says the plate, the cover plate is 27 by 1. So that D value is just the overall height. It's not Y bar. It's not Y bar. Okay? So be careful on that. It doesn't actually give you don't get that anywhere, do you? You'd have to calculate that, wouldn't you?
How did you get that area A1 is equal to 11.2?
That's in the back of the book on page 491. Okay, and I'm going to do something here. I got to get these out of here. I don't like this. Is going to screw up my problem, I think. You can remember that 348, but that's what we're supposed to be calculating, isn't it? We're supposed to eventually be calculating all that.
Well, we're supposed to calculate for the entire object.
Well, actually, we do need to know that moment of inertia
Yeah. 'Cause you can't-
for that one, because that's too hard to do.
Pretty close anyway. That's page 491,
Yeah, and I didn't copy that and didn't scan it in, so I apologize if you're watching this at home. But yeah, the C15 by 40 is the second column down in that table C1 on page 491. It gives the moment of inertia about the x-axis at 348. We don't know that for the other one, so we're going to have to go in here and do some serious work, aren't we? Well, let's see. Y bar for 1 and Y for 1 and 3, if you will, 1 and just 1, I guess. What's that going to be? Well, we said this D value was 12, 15. That's where the 15 comes from. It's C15. The C15 to 15 stands for the length of this piece, and I believe the 40 is 40 pounds per foot. I think is what that actually stands for. Okay, so when it says C15 by 40, it's 40 pounds per foot of weight. Just like on the, so if it was a C12, then that D value should be 12. Does it give any weights in here? I don't think it does. But that's what that designation's for. Okay, so Y1 is going to end up being 15 divided by 2, right? The height divided by 2, and that's about, what, 7.5 inches. Y2 is going to be what? 15 plus a half inch, right? 15 up to the plate plus 1 divided by 2 is 15.5. What else do we need? Anything? What? Well, we're going to have to calculate that, aren't we? Yep. We got the area on both of them. We need to do Y bar, don't we? For the whole thing. Without Y bar for the whole thing, we can't figure out any can we figure out the moment? We could figure out the moment of inertia just for the plate, couldn't we? So y bar is what? The area of the first one, 11.8 square inches, times y1, which is 7.5 inches, and that value is squared, isn't it? Or no, that's not squared. Sorry. Trying to do this from memory, and for an old guy, that's not necessarily good, is it? That's just what it is. Plus, oh, and let's do one thing here. Can we do this? Can we just say that value, all of this, if you will, times 2? Takes care of both of those C channels, right? Plus, and let's see, we'll put that in parentheses, plus the area of the second one, which was 27, times y2, which was 15.5. All of that divided by the areas, right? Which is, whoops, 11.8 times 2 plus 27. What's that come out to? It should come out to 11.77. That's correct, because the square inches cancel out because of the areas. 11.7 inches, and that's what you're looking for, isn't it? You're looking for that distance from the base up to this x axis.
We got 11.7.
Yeah. That's what it should be, somewhere in that 11.7 something.
11.76.
Okay. Now what? We could actually get the D values then, couldn't we? The D1 and D2. Put them right here. So that's Y1. So 11.7. This is to transfer. Minus 7.5. And D2 is going to be 15.5 minus 11.7. Again, that's an absolute value because the D value gets squared anyway, right? So let's see, 11.7 minus that, that's a 2, and a 4 inches. And 15 minus 7 is 8. 4 minus 1 is 3. 13.8. 3.8. Yeah. Thank you. My eraser's too big now. Good thing I wasn't giving anybody change, huh? I'd been short $10. Okay, so we know that. Now what else do we need? Do we still need the moment of inertia for the, let's say, the plate? Okay, so the moment of inertia for a square piece, base times the height cubed divided by 12, all right? So the base is 27 times 1 cubed, and that is cubed, by the way, divided by 12. Punch that in real quick.
2.25.
2.25 inches to the fourth. Okay. Now what?
Other subs.
What?
Eyepiece.
What? Oh, you're saying that's the next thing we do? So you're saying that we need to do a moment of inertia about the x-axis axis is going to be the moment of inertia of each piece, right? So 1 plus the area times d squared, right? And then we do a summation of all those. Okay? That's where we're at, right? Did somebody have a question?
We're figuring out that that PO is for the plate.
Yes,
So that's the moment of inertia for the plate.
that's correct. And we already have the moment of inertia for the C channel.
Yeah, that one, we just looked off the chart.
That what?
We got it off the chart.
That's correct. We got it off the chart. But we didn't get the plate. There are no charts in the back of the book for the plates because it's just a rectangular piece. So then we went to table 3 to find the moment of inertia of that plate, which is just a rectangular piece or a square, right? So it's the base times the height cubed divided by 12. So now we have enough information to do this problem. So we'll go in there and we'll say the moment of inertia on the x-axis axis for this whole problem.
Summation I.
What?
Summation I plate.
Yep.
Summation I plate plus.
So we can do 2 times the moment of inertia for the C channel, which was what, 348?
Yep.
Or can we do 2 times on this? I think we can. Plus, now we got to do 2. Well, actually, we'd just do this, wouldn't we? Plus the area. What was that area?
11.8.
11.8. Okay. In unison. Times, what was our D value? 3.8 squared. Okay. Do what? What's?
3.8 is for the plate. Yeah.
Oh, okay. So we got to go back and change that value. This value. You said it was 4.2? Who gave me? You're one of the ones that said that was 3.8, weren't you? I won't mention your name on here, Jabril, so nobody will know that's watching.
Oh, we corrected his own mistake, though. We have no credit for that.
Or was that? I just put the wrong number back in, didn't I?
Back in there, yeah.
I'm blaming that one on you too. Is it Friday? Oh my goodness.
Saturday right now.
Well, I remember Wednesday I was thinking we were, or the other day I was thinking we were already at Friday. Okay, 4.2, right? Oh, you bunch of jokers. Plus, the moment of inertia for the plate, which was 2.25, plus the area of that plate, which was 27, wasn't it? I left some units out there, didn't I? Times, what's this D value? 4.2? I had it written down almost before I said it.
I got
It's
3.73.
3.73.
Oh, you're using 11.7 for that, instead of 11.77. That's just a rounding thing.
Yeah. That is the moment of inertia about the x-axis axis for those pieces. When you punch that in, you should get something like 1506, I hope.
1504.
Okay. 1504, see the solutions manual says 1506, but we're rounding different than they're rounding. Okay?
So the only way to check that on CAD would be you'd have to import the C channel
Yeah.
basically.
Yeah, we'd have to get that C-channel shape exact, if you will.
Yeah,
We could do that.
yeah.
We could get that in there, but it'd be a little bit of work right now for what we're trying to do right now.
Yeah.
So that gives you the y bar for that, and then the moment of inertia for that particular makeup of those three pieces. Okay. Well, let's see. I think I had one more I wanted to go over here in class. Oh, well, that's, yeah, we did the other example, so that's pretty much what I wanted to do. That makes sense? So we're starting to put things together here now. Okay, here's what I want you to do for homework, for practice, additional practice. Out of chapter 8, do problems number 13, 15, 23, 24, and 31.
You said 13, right?
13, 15, 23, 24, 31. Now, just do the x-axis, okay? Some of them, there will be a couple problems in there, polar moment of inertia. So give those a try. And like I said, if you run into a jam and you want some help, take a picture or scan it, send me an email. When I get the email, I'll look at it, look over the problem, see if I can figure out what you're doing wrong. Hopefully I can. I'll shoot you back an email saying, well, you need to maybe adjust this or this. Then whenever you get the chance to look at it again, you know, don't sit there waiting on me. Okay? I'd have to give you my phone number to do that. And I might be right in the middle of my backswing. You know? So, you just never know.
You're really bad if another guy was in the middle of his backswing and your fan went off.
Well, but I can turn the ringer down and still, I can hear my phone through my hearing aids. So, yeah.
It's like your phone's ringing and you're hearing it?
Yeah, but you don't hear it. That's why sometimes when I'm in class, I'll pick my phone up and hit that button because my phone's ringing. As long as I've got the ringer turned off.
That's cool.
Yeah, I almost forgot them this morning. I was about a quarter mile down the road and had to turn around and go back. Told my wife, said I spent big money for these. I probably ought to wear them. So
test on Wednesday.
no, I don't think we'll have a test on Wednesday. Let's make sure we got the homework down. And then we'll figure the test on Friday. And that might have been part of our problem last week. We might have rushed it a little bit. So I'm hoping that we'll plan on working, make sure all these problems are squared away by Wednesday. Okay? Do the problems and come in and do what Chris did earlier. He came in and said, well, I had problems with number 9. Here's what if you don't do the problems, you're not going to know. It's going to be too late Friday. Okay?
This one's just hard.
Do what?
How you want?
Hold on a second. Let me